The emergence of Python as a general purpose language. What's the history and where are we now? Well, Python was created in the late 1980s by Guido von Rossen, with version 1.0 coming into play in January of 1994. So as you can see, it's been around a long time. That's a pro for the language. It's been around a long time, and so there's a lot of people that have expertise in it. It's easy to use interpreted language. It's object-oriented, strongly typed. It has generic types, and as versions have occurred over the years, it's incorporated some of the more functional concurrent programming capabilities, like a lot of modern languages have. BASIC was an early language back in that time frame. 1990 in the 1980s is a pretty early for personal computing, so it's been around a long time. BASIC was another language that was into play there, and also an interpreted language. JavaScript is an interpreted language. There's no compile time mechanism required to run. You just type in human readable text and send it to the Python interpreter, and it runs the program. That makes it easy to use, and it helps with some widespread adoption. And it also is a reason that it's very popular in academia. A lot of, besides computer science courses and things like that, it's used in a lot of postgraduate research for mathematical calculations, for programs that need to be done for scientific reasons, data analysis, and of course, as I'm going to talk about, AI. It's open source, which is another benefit, which means it's free to use. It's supported by the not-for-profit Python Software Foundation, and as they say in their charter, it will be free forever. And that's another compelling reason to use a language. And it's supported by a foundation that maintains its safety for security reasons and puts new features and versions out. What are some use cases? Originally it was a kind of a scripting language, I think, where a lot of folks used it when it came out for some general purpose type programming, utilities and such. But since then, it's become what we would call a general purpose language, where you can build anything with it. Some very popular use cases are data science, statistics, math, AI, scripting, general purpose programming, web apps, server-side implementations have all come into play with Python. I think some of that, I believe a lot of that is due to the AI emergence. Python is a great language for scientific computing and numerical processing, and it's been used prolifically in AI spaces for neural net usage. ChatGPT's algorithm is a sophisticated neural net per se, and Python is what it's implemented or tested in and been validated in. And the reason that is because of the scientific background. It has a lot of matrixy type mathematical capabilities built into the language, and neural nets rely highly on matrix mathematics, matrix calculations that are required for that to work, for neural nets to work effectively. And Python that's been built into the language for a long time, so it has those processing. So researchers can use the language. It's easier to use, and they can try these ideas out. That's where part of the killer use case for Python is generative GPT. So that's for the scientific uses in academia and the current AI, but it's also that I believe that spurred its usage in enterprise computing, which something Keyhole does a lot of, where general purpose computing, such as a web application, you go to a website where you can do any kind of what we call create CRUD type of programming, inventory control. That's what we would use a general purpose language to do something like Java on the server side or .NET on the server side. When you use Python for something like that, you shouldn't use Python as is. Out of the box libraries and frameworks are available, but the best practice would be to come up with a structured application architecture, where you have to have API support for the server side. The browser talks to the server and needs to access business logic and data persistency on the server side. That's what we call API support. In Python, there's frameworks that support that. You would use something like Django, Flask, Fast API, Falcon, Tornado, to name a few. These are all Python frameworks that are open source that you would use to help implement an API for an application. Another element of an application architecture would be OR mapping, object relational mapping. That's for persistency, where we have objects and data structures that the Python application would use, specifically the API, and we need to talk to a database to persist that stuff. That's where we get into the reading, writing, updating, deleting of data in a database somewhere. It could be a relational database, it could be a NoSQL database. In that case, there's frameworks such as SQL Alchemy, Django, Peewees, Pandas, and others, but you would want to have some kind of object relational mapping framework in place to ease talking to the database. And that's, again, a framework that you would use with a Python framework in that space. And then the version of control or dependency management, that's an architectural pattern that's best practice when developing applications, especially when there's a team of developers working on it. That really doesn't exist in Python, but you could use constructor injection or different patterns out there and roll your own, but we would recommend using some kind of dependency injection or version of control framework to do that. And again, that would lend itself to maintainability, scalability, and team development. And dependency management. I'm talking about all these frameworks that we're using to honor this Python application architecture. So a dependency management is very important. pip environment, PDM, Poetry are some dependency management libraries that are utilities you can use. And it's, again, for team development, you need to have that. You're bringing all these versions of frameworks in and out. They need to be managed. Your development team needs to know which ones are prevalent, and these dependency management libraries help out, as opposed to other languages such as .NET or Java. It's a little behind Python, the ecosystem on this. They have like globally managed dependencies, and they need sometimes some of these trying to manage these things granularly can be difficult with pip. So these other frameworks are a little better options for it, especially when you have a team environment going on. Another element of your application infrastructure, architecture, or lifecycle should be unit testing and integration testing. When you have a lot of hands in the pot and a lot of features and functions you're developing, and you want to move out or get out the door, unit testing is a best practice. And there's some frameworks involved: PyUnit, PyTest, DocTest. These are all things that are available to help your team implement and execute unit tests. And of course, integration testing is also a big factor in that too. Finally, all the IDE support, integrated development environments support Python, VS Code, IntelliJ. You can all are Python sensitive to syntax coloring and code assist and things like that. If you need some help on Python or developing with it or establishing an application architecture, feel free to give us a call. Just drop a note to ask the team at keyholesoftware.com.